샛별
Do you find math uninteresting? Are you not having fun with mathematics? But do you know that we can have fun with mathematics? Or do you need Miss Math Magician to enlighten you with all this? Hello everyone, back on the game again. I am Miss Math Magician, your math study buddy, aka game partner for today, saying I am not a magician, only a mathematician. And yes, you heard me right, game partner, because in today's video, we are going for some roller coaster fun with mathematics. Now, do you accept the challenge? That's the spirit. I love it. I know you will say yes to learning. But not only that, at the end of this video, I can guarantee that you will have so much fun experience. This video includes 3 different games, and there will be an explanation of how we obtain the answer. Let me introduce you to our game 1, Math Bingo. In a typical bingo game, a moderator will call out numbers, and each player will cross out those numbers if they have them on their card as the game progresses. Math Bingo is like the regular bingo, but with a twist. Instead of calling out numbers, I will be giving you fun math problems to solve. You will solve each math problem, and if you have its answer on your bingo card, you will cross off that corresponding answer. And if you don't have the answer, skip it and prepare for the upcoming math problem. In a math bingo game, you only need to cross off 5 boxes in a row to win. It can be 5 in a row, horizontally, vertically, or diagonally. In this game, we will have 2 cards, one for you and one for me. In the letter B, what is the 11th term of Fibonacci? In the letter B, what is 3 raised to 11? In the letter I, what is the next term in the series 2, 5, 8, 11, and 14? In the letter I, what is the logic symbol for the conditional proposition? In the letter N, what is the logical symbol for disjunction? In the letter N, what is the square root of 11? In the letter G, look for a number that is factorial with 4. In the letter G, what are the coordinates of the origin? In the letter O, what year is today? In the letter O, as I said earlier, how many games will we play? And we have a winner. And I will explain how you obtain the answers in the game. Our first letter is B, and the problem was, what is the 11th term of Fibonacci? To obtain this, let us recall the formula for Binet's formula to answer the next terms in Fibonacci. But before that, since it's still countable, you can presume to add the preceding 2 terms of the series. So, the series turns out to be 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, and so on. However, if we want to follow the Binet's formula, it is f sub n is equals to 1 divided by the square root of 5 is equals to 1 plus 5 divided by 2 raised to n minus 1 minus square root of 5 divided by 2 raised to n. Do the substitution of f sub n to f sub 11 and so on. We will still have the answer of 89. Learn more about Fibonacci and Binet's formula through Math TV. You can see that B, 89 is in your card. After that, the following letter is B again. And the problem was, what is 3 raises to 11? To obtain this, it means we have to multiply 3 11 times. You can use the calculator. If you have a scientific calculator, it is much better. Answer 177147, which is on my card. On the third call, I, and the problem were, what is the next term in the series 2, 5, 8, 11, and 14? In this, we find the common difference between the preceding terms, and that is 3, and add it to the current last term. 14 plus 3 is equals to 17, and the same process goes to the following term. But what if we have a higher number, or want an easier way to solve this? Then, we will use the formula or arithmetic formula. A sub n is equals to a sub 1 plus quantity n minus 1 times d, where n is the nth term in the sequence, a sub 1 is the first term in the set of numbers, and d is the corresponding difference between terms. Look, I also have 17 on my card. Next, in I again, the problem was, what is the logical symbol for the conditional proposition?
The symbol of the conditional proposition is the right arrow.
Its English words include if then, when, otherwise, thus, since, hence. For example, here we may read this as if S then Q, if 1 plus 3 is not equal to 5, then this math magician is watching. And you have it in your card again. On the fifth call, we have N, and the problem was, what is the logical symbol for this junction? The symbol of this junction is the lowercase letter V in the English alphabet or wedge. We use the equivalent English word or, either or, whether or, to connect statements. For example, read as in N, P or Q, this math magician is either reading or watching. And you can see that you have it on your card again. One more, then you will be the winner. On the sixth call, we had N again. And the problem was, what is the square root of 11? The square root of 11 is 3.3166247903, which is also on my card. Wow, the game was getting intense. Do you agree? Then, the following letter was G, and the problem was to look for a number that is factorial with 4. As 4 is an even composite number, it has more than 2 factors. Recall prime factorization. Thus, factors 4 are 1, 2, and 4.
There was another call in letter G, and the problem was, what are the coordinates of the origin? And that is 0, 0. Right. Recall the Cartesian plane. Origin is 0 on the x-axis and 0 on the y-axis, which is on my card.
Second to the last, we are asked, what is the year today? It is 2022. And here's a trivia. The square root of 2022 is 44.96665431119. However, it was not on our cards. And this last question made us a tie winner. As I said earlier, how many math games will we play? 3 games, that's right. And may I request you to comment on at least 3 things you learned or fun activities you gained after watching this video. And finally, both of us have this in our cards. We crossed out 5 out of 5 in our cards, but we are only starting. We just played 1 game over 3. Then, let us not wait any further. Now, let me introduce you to our game 2, Modular Art. Here, we divided 4 quarters like in the Cartesian plane, with quadrants 1, 2, 3, and 4. Per row and column, we have 4. Then, the pattern boxes are called a legend. In doing your modular art, you can apply your style in designing it. We will number the boxes 0, 1, 2, and 3. Now, you will see that I will fill the plane with number patterns. Quadrant 1. In the first row, we have 0, 1, 2, 3. In the second row, we have 1, 2, 3, 0. The first number that will be at the preceding terms is the number that is in the first number series of 0, 1, 2, 3. In the third row, we have 2, 3, 0, 1. In the fourth row, we have 3, 0, 1, 2. Quadrant 2. We will fill the upper right side with the vertical numbers or the first column of quadrant 1, which is 0, 1, 2, and 3. Fill it horizontally. In the first row, we will have 3, 2, 1, 0. These are the numbers from the vertical column in quadrant 1, starting from the bottom to top number. In the second row, we will have 0, 3, 2, 1. In the third row, we will have 1, 0, 3, 2. In the fourth row, we will have 2, 1, 0, 3. Quadrant 4. We then fill the lower right side with the horizontal numbers of the first row of quadrant 2 with 3, 2, 1, 0, and fill it vertically. In the fourth column, we will have 3, 2, 1, 0. In the third column, we will have 0, 3, 2, 1. In the second column, we will have 1, 0, 3, 2. In the first column, we will have 2, 1, 0, 3. Quadrant 3. We then fill the lower right side with the vertical numbers of the fourth row of quadrant 3, which is 3, 2, 1, 0. and fill it horizontally in the third row of quadrant 3. In the fourth row, we will have 0, 1, 2, 3. In the third row, we will have 1, 2, 3, 0. In the second row, we will have 2, 3, 0, 1. In the first row, we will have 3, 0, 1, 2. And there you have it. We have completed the pattern that we will be filling later. Now, fill the corresponding patterns with their legends or design. But we still have the following steps. Fill in all the 0 in the quadrant 1. Next, fill in all the 1 in the quadrant 1. Next, fill in all the 2 in the quadrant 1. Next, fill in all the 3 in the quadrant 1. Quadrant 2. Before filling quadrant 2, let us rotate the legends to the right at 90 degrees. Observe the placing of the legends. Now, fill first all the 0, and then all the 1, and all the 2, and all the 3. Quadrant 4. Before filling quadrant 4, let us rotate the legends to the right at 90 degrees. Observe the placing of the legends. Now, fill first all the 0, then all the 1, all the 2, and all the 3. Quadrant 3. Before filling quadrant 3, let us rotate the legends to the right at 90 degrees. Observe the placing of the legends. Now, fill first all the 0, then all the 1, all the 2, and all the 3. Now, we can see that we are successful in this game. Seeing the output, I must say, we've done a great job. Let me introduce you to Game 3, Matchstick Puzzle. Here, we need to match the stick to the equations. These are brain teasers to test how sharp your logic are. How can one match be shifted to make the equation true? You have 10 seconds. Did you get it correct? Let us check.
Here, we need to move one stick because 5 minus 5 is equals to 9, not 6.
Now, let us shift one stick from 9 to make it a 6. We then have 5 minus 5 plus 6 is equals to 6. Move on match to fix the equation. You have 10 seconds. Did you get it correct? Let us check. Let us shift one match from 8, making 5 and 9. We then have 9 minus 9 is equals to 0. Remove 2 matches to leave only 4 equal squares. You have 10 seconds. Did you get it correct? Let us check. Here, we remove one stick from the left and one from the bottom. And that's the end of today's activity. I hope you learned and had fun. Again, I have been your math study buddy, aka game partner, Miss Math Magician, saying, I am not a magician, only a mathematician.